Today we're heading to one of the brightest and most powerful objects in the universe, the Phoenix Quasar. Using the SpaceEngine planetarium, I'll fly right up to it and show you what this giant cosmic energy source looks like. And we'll also see what the Phoenix A quasar might look like from the nearest planets surrounding it. Phoenix A is an extremely powerful quasar, linked to the central supermassive black hole of the Phoenix Cluster galaxy. This object is located at a distance of approximately 8.5 billion light-years from Earth. The quasar's energy originates in the accretion disk around the supermassive black hole, where falling matter heats up to very high temperatures and begins to radiate intensely across various ranges of the electromagnetic spectrum. The mass of the central black hole is estimated in billions of solar masses, from 20 to 100 billion masses, and the luminosity of such objects can reach values comparable to, or even exceeding, the luminosity of entire galaxies. The Phoenix A quasar hasn't been officially added to SpaceEngine by the developers, so I installed a mod from the Steam workshop. If you want to install it yourself, the link to the mod is in the description. I've flown closer to the central black hole. I've set the planetarium to ultra graphic settings, so if it lags a little bit, please excuse me. But the main thing is that the image will be of the highest possible quality. I'll go lower toward this accretion disk. Look at how all of this looks visually. And now I've flown right inside it, you can't see anything at all here. And just imagine how massive the radiation is here. Now I'll fly closer to the black hole. Right over here, you can see the silhouette of the black hole here. So this is the edge of the event horizon, I suppose. Literally the edge, and now I'm going to go inside this black hole. In the SpaceEngine planetarium, when you go inside a black hole, everything turns white, so I'll break back out. Now I'll switch to the automatic photo mode. In this mode, everything looks like this kind of accretion disk. It's almost even more beautiful this way. Take a look at these textures of the accretion disk. It looks absolutely wonderful and vibrant. Wow, and look at that outgoing jet. That is really quite something to behold. I had the idea to show you this jet and how it looks from this kind of angle. And there we see that massive central black hole, and that is how the whole thing looks. Cool. And now I've descended to the edge of these accretion clouds. This is how everything looks here. Wow, it looks absolutely amazing. And what an incredibly bright and intense light if you look into the center of this object. Look here once more. Well, it's truly and completely wonderful. Also, if you look at it like this, what a pillar, right? Just try to imagine the massive size of this celestial object. It is terribly huge. I'm switching back to HDR mode. And what really surprised me was this star orbiting right near the event horizon. I will fly a bit closer. It is some kind of star, an orange dwarf, but how can it even orbit here? Anyway, you can see for yourselves that the fact of a star being here is real. And now I'll search for the nearest planets to this Phoenix A object. To do this properly, I'll just fly into the event horizon. I'll stop somewhere around here. Now I need to select the star browser. The search radius will be 10 light-years. I'll go into the filters and uncheck the Ignore Planets box, because Planemos here could actually be the closest planets to this object. Starting the search. Well, it found quite a lot of objects, and the closest planet to this quasar is at a distance of 0.61 light-years. And it's not even just a Planemo, guys, but a complete full-fledged star system. Anyway, flying there now. And here we have two red dwarfs, and they have their own planets around them. Let's pick the most interesting planet for viewing the quasar. Well, here's an interesting planet with a temperature of minus 94 degrees Celsius. It has an atmosphere of decent density. This object will do. The object is quite desert-like. The pressure here is 15.5 atmospheres. Nitrogen, carbon monoxide, and carbon dioxide make up the atmosphere. You can see it even from space, that's how close this quasar is. I'll descend on the side where it'll be visible. I'll speed up time about 300 times and we see the clouds moving against the backdrop of this massive quasar, or rather against the large accretion disk around the black hole. This is how the whole thing looks. I've turned down the graphics to make everything run a bit smoother, and even from here you can see a neighboring planet in this system. Let me show you through the telescope how it all looks. Here's a planet with rings like that. If we speed up time more, the quasar will move across the sky, and that's how it'll set below the horizon. Such a massive weight. Such a huge massive object is setting here behind the horizon. Incredible. And it can't even set completely. It envelops the entirety of the planet's sky everywhere. The star is rising now, and the quasar isn't as bright immediately. Well, it's clear enough here, and it has risen again. Wow, this massive behemoth has finally risen up, so to speak. And we can see how it all appears to us during the day. Now I suggest we look at a planet at a distance of 10 light-years from this quasar, and here we have a system exactly 10 light-years away. There's an orange dwarf here, I'm flying there now. And besides the orange dwarf, there's also a red dwarf in the system, a binary star system like like that. Found it the second planet in this system, a cold desert like Terra. It has a fairly dense atmosphere of carbon dioxide and nitrogen. The average temperature is minus 104 degrees Celsius, and the surface pressure is 20.5 atmospheres. The planet is tidally locked to its star, and from here we can see Phoenix A. I'll descend to the day side first. This is what it's like on the surface during the day. And we can see Phoenix A in the sky from this planet even during the day. And interestingly, one of its jets is very clearly visible. Since it's tidally locked, there won't be a sunset in this location. To see Phoenix A at night, we need to move. And here I am on the dark side of this planet, and look at this cool view of Phoenix A. I'll speed up time. Wow, how brightly it's changed by this black hole. That certainly looks interesting. What if we switch to automatic photo mode? Wow, that looks so cool. Just how incredibly bright this object really is. Even from a distance of 10 light years, the object is very bright. Switching back to HDR, and now I've got a cool idea. Savoy. I'll search for a relatively close planetary system with a life-bearing planet near the Phoenix Quasar, and it'll be interesting to see how things are there. Right here in the system browser, there are several systems showing that there is one planet with life. I'll choose the closest one available. Here is a system already at a distance of 0.9 light years away that contains life. Let's check what kind of life is living there. Oh, we've got some complex life here. A cold Terra with life. Well, in that case, let's fly to that planet. And here's such an interesting planet. The temperature is listed as minus 86 degrees Celsius. The surface pressure is almost 7 atmospheres. The atmosphere consists of carbon dioxide, oxygen, nitrogen, and water vapor, and liquid water on the surface. The planet is tidally locked to its star. The diameter is 15,578 kilometers, and its mass is almost 2 Earth masses. And we're so close to this quasar, how can there even be life here at all? There you go, life is represented like this here. Something is growing on the surface over there, and it has such a purple atmosphere. Cool. And here's a view of this huge quasar. Wow. I'll speed up time. And this is how the quasar moves across the sky. If you switch to automatic photo mode, everything looks something like this. Here we see a dark silhouette. This is a red dwarf star, which is just like a black disk against the background of this bright quasar. But if you switch to HDR, the star's brightness is of course clearly visible. And so this quasar sets below the horizon during the daytime. I've relocated myself to the twilight zone on this planet, and this is the clear view of Phoenix A. I've boosted the graphics a bit, so we can appreciate the higher quality textures of Phoenix A. I also picked out this beautiful view of the star for you. But if we look at this quasar again, we see a jet that covers half the sky for us like this. But the main thing is that this jet isn't aimed directly at this planet, or it would be very bad. And take another look at this majesty setting below the horizon on this planet. Also guys, I found a rather interesting planet at a distance of almost 6 light years from this quasar. Let's go, I'll show it to you. That planet also has life. This planet, as you can see, has its own ring system. In auto mode, the planet looks like this. About the planet, here we have nitrogen and oxygen in the atmospheric composition. There is liquid water on the surface. The average temperature is 20 degrees Celsius. The planet is larger in diameter than Earth, 15,204 kilometers, and the mass is 1.72 of Earth's mass. And this is a temperate marine Terra with life. And there's the quasar. The jet from the quasar is almost aimed here, descending to the surface of this planet. How beautiful it is here. Here we have vegetation, life. Look at this. 6 light years away from quasar Phoenix A. And such a beautiful surface and a beautiful sky with clouds. Oh, we see the quasar. How nice. We see a star. It is indicated here that we have a binary star system. It is an orange dwarf and a red dwarf. It is a perfect vantage point on this planet. Now you see the star slowly setting behind the horizon. And after the star sets, Phoenix A will also set behind the horizon. Enjoy the view. This is what one of the most powerful objects in the universe looks like, Quasar Phoenix A. A huge supermassive black hole at the center of a distant galaxy emits so much energy that it can outshine the light of billions of stars. If you were interested in seeing this object in SpaceEngine, support the video with a like and leave a comment. Thank you very much.